All righty, guys. So our next section is going to be about angle proofs. But what we're going to start with is, just like we have been doing, what are some of the properties we can use? What do they mean in context? And how can I know what they are? So this is what this looks like. This is our angle proofs reference. We have our properties of equality right here at the top that we've been using. We have the properties of congruence that we used in the last segment. And then we have some new ones. We have the definition of congruence, but this applying to angles. We have the definition of a right angle. An angle that measures 90 degrees is called a right angle. We have the definition of complementary angles. I believe you learned that in Unit 2. So two angles are complementary if the sum of their measures is 90 degrees. The definition of supplementary angles is when they add to 180 degrees. An angle bisector is a line that divides an angle into two equal parts. And the definition of perpendicular is that perpendicular lines form right angles. We have the angle addition postulate, which you've learned about last unit. And then we have a few theorems. Okay, you've already learned the vertical angles theorem, is that if you have angles that are across from each other like this, the angles right here are congruent to each other. And the angles across this way are congruent to each other. So you might want to put a little picture there for reference. You're not going to use this one much, but it's here. If it freaks you out and you have one in your word bank, just let me know and I'll help you through that one. It says if two angles form a right angle, then they are complementary. It's just kind of a theorem, but it's really more of like, that's what the word means. Linear pair theorem is supplementary. So when you have angles that look like this, they are on a straight line. Wow, that's a terrible straight line. And let's say you have an angle like this. These, I'll put a little letter here. A plus B adds to 180. Okay, that is forming a linear pair, and those are supplementary. Congruent complements is if A is complementary to B and C is complementary to B, then A is complementary to C. So it's almost like using the transitive property and taking out the middleman, but with complements and congruent angles instead. We have the same thing for supplementary. So these two are just a little bit weird. If you get to those and you're stuck, just let me know. But for now, you're going to start with this. I'm going to put in a few of these for you, and then you're going to practice and come back. Let's do this one. It says if this is a picture, then angle 1 is congruent to angle 2. Well, look right up here. We drew that picture. That is the vertical angles theorem. You're going to use this one quite a bit, so I want to make sure that you know what that one looks like. I'm going to write vert angles theo. You can write it however you want, as long as it makes sense to you. If angle W and angle X are supplementary, then angle M plus angle X equals 180. Oh, also about this time, I usually have questions about what is this M? Okay, what is that M? That means the measure of, like how many degrees it is. And that's how we read it. We say, then the measure of angle W plus the measure of angle X equals 180. Anyway, so that was a side note, but this is the definition of supplementary angles. So I'm going to write def of sup angles. You guys like how I slow that down? You can do that. All right. If the measure of angle R equals the measure of angle S, then angle R is congruent to angle S. That is the definition of congruence. Because we've changed from equal signs with the measures to being the congruent sign. Right, so you've got your reasons bank down here. When you see me again, we're going to start onto these proofs.